Now let me just show you the actual article itself. You'll notice that you're probably looking for some metallic luster there, but you won't see it because the calcium has corroded in the oxygen of air. Oxygen is actually very reactive. People don't give it its full appreciation. You need it to live, but it's killing you slowly. All right? It really is. It reacts with you, and it's a greedy little sucker that wants a lot of electrons. Anyhow, and it's already taken some of the calcium electrons here, and you see the calcium oxide coating in the outside. But we can speed this up a bit. I'll throw a few chunks into some water, and I want you to see the reaction. It will begin slowly as the water sort of gets in there and reacts with the raw metal. Don't worry, I'll pick it up just for a moment, but it gets so hot I'll have to put it down. All right. What you'll notice is a couple of things will happen here. First of all, you'll see some bubbling going on, and the calcium hydroxide, which we spoke of, will be created. Now, in the very beginning, the calcium hydroxide will dissolve, but it quickly gets so much calcium hydroxide that the water can't dissolve it, and it starts to precipitate out as a white cloud. And it'll actually look like milk, but I wouldn't dare drink it, because calcium hydroxide is nothing like milk, I can assure you. So here we go, down it goes, and there you see the bubblings, right? Now you see it remains clear in the beginning. Calcium hydroxide is being produced. Also the bubbles, of course, is hydrogen gas. Okay, now you see the violence increasing and increasing, and to be safe I need to put it down here. Okay, I'll put it out towards the edge so you can see it. You might now see some of the whiteness of it. Now I want to capture that hydrogen gas, very light gas. I have to capture it upside down like this. Okay, please light that. Alright, I'm capturing some hydrogen gas. Okay. Light the split, please.
It's not going.
Right. Shout out.
It's like sticking.
Alright, please give me the lighter. Hold the splint, please.
You need a lighter. This wasn't the only one.
A little bit of experience helps. Alright, ready? We're going to explode the hydrogen gas. Ready?
Where'd it go?
You never know. Sometimes more violent than others, but there it was. And now let's examine what's gone on here. Notice it's now milky white. That's calcium hydroxide that's in suspension at this time in the water. Now it will precipitate out and separate and leave a clear liquid above, and then it'll all lay on the bottom. But it looks a lot like milk, doesn't it?
Yeah.
One could be easily deceived. It's always good to be careful around these chemicals. So there's the reaction of calcium with water. Anyone care for some calcium?
Yeah.
No. Calcium ions only, please. Make sure you specify.
Blow that up.
Can I blow up?
Milk.
Milk's not explosive. However, in my practice round, I did put a little bit too much calcium in, and the reaction was so violent that it had a bit of a volcanic eruption. It looked like Krakatoa. No, I don't want another Krakatoa. One Krakatoa is enough. You guys ever heard of Krakatoa?
Yeah.
What do you know about Krakatoa?
It's like the sleeping, but it's really loud.
No, Krakatoa was a horrible volcanic eruption that occurred in 1883 on the island of Krakatoa, which actually destroyed the island in the South Pacific. So much ash and smoke went into the air that day that the next summer, there wasn't a summer. It was a year without the sun. Man, it blocked the sun. In fact, the sky was red for like a year, all around the world. It was kind of cool, although not really what you like. It dropped the planet temperature 1.8 degrees Celsius from a volcano like that. So we can't have another Krakatoa, you guys. Although that would solve the global warming issue. At least temporarily. At least temporarily.
And we have more snow.
Oh, we can't have that. All right, guys, let's go back.